Hey guys, welcome back to the QST YouTube channel. Today we'll be solving section 4.4. Iron oxide F2O3 reacts with carbon monoxide CO2, CO, to produce iron Fe and carbon dioxide CO2 as shown in the following equation. If 400 grams of Fe is mixed with 336 grams of CO, which of the following would be the limiting reagent? Look, here all we need to do is find the moles, first of all, by for each one, by doing mass over molar mass. So the mass of Fe2O3 is 400 over the molar mass, which is 112 plus 48, which is 160. Let me do it on the calculator. 400 divided by 160. Okay, that will give us 2.5 moles. Okay, so let me erase count. Okay, so we have 2.5 moles, and then we're gonna have to find the moles of CO. So the mass of CO is 336 divided by the molar mass, which is 28. 336 divided by 28, which will give us 12. Okay, to find out which one is limiting and which one's excess, we divide the moles by the coefficient. So here we do over 1 because here Fe2O3 has a coefficient of 1. Okay, so we divide by the coefficient. So here we get 2.5 over 1, which is 2.5. And then this is 3. Okay, so if CO is 3, meaning that CO is the excess. But over here they're asking for the limiting, which is less, which is Fe2O3. Water can be split into oxygen and hydrogen according to the equation below by adding to it sulfuric acid and running an electric current through the solution. The reaction of decomposition of water is classified as endothermic because they said here that we need to run an electric current through the solution, meaning that we need energy. Calculate the masses of H2 and O2 if 27 grams of water is used during the reaction. First of all, we need to find the moles of water, which is 27, which is mass over molar mass. Here they gave us the mass, which is 27, divided by the molar mass, which is 18. 27 divided by 18 will give us 1.5. Okay, so now we know that we have 1.5 moles of H2O. First, let's find out like the the mass of H2. Since here we know that the ratio of moles between water and hydrogen is 1 to 1. This means that the moles are the same. That which will help us finding the mass of hydrogen. 1.5 is equal to x, which is the mass, over the molar mass of hydrogen, which is 2, which will give us x is equal to 3 grams. Now, to find the mass of O2 by the law of conservation of mass, we can just simply do 27 minus 3, because mass is always going to stay the same between the reactants and the products. So 27 minus 3 is equal to 24. Calculate the mass of water needed to produce 128 grams of oxygen. Okay, so now we need to find out how many times, first of all, we need to find out how many times we need to multiply oxygen to get to 120, to multiply the mass of oxygen to get to 128 grams. To do that, we do 128 over 24, which will give us 5.33. Okay. Now we need to find the mass of H2O. Actually, no. Okay, so as I said for this question, we're gonna have to balance the equation. Just let me. Okay, so we have C. No, my God. Wait. So the unbalanced equation is C4H10 plus O2 will give CO2 and H2O. So let me split it. So this is the reactant, this is the product. Here we have 4C. Cannot do this. Okay, so as I said, we're gonna have to balance the equation. Okay, so here we have okay, so oh my god. Okay, look, so we have on the reactant side C, we have 4C, we have 10H and 2O, right? And then on the product side we have 1C, and then O2 plus 1, and H we have 2. First, let's balance the carbon by making this 4, which means this will be, instead of 2, 8 plus 1, right? Okay, so now we balanced the carbon, right? Okay. After that, we're gonna have to balance the hydrogen by multiplying the H2O by 5. H2O. So this is 10, and then this is 5. Right. And then instead of O2, we can simply put here 6.5. Okay. And then we have everything. So let me remove this part, then this part. 6.5. Okay, so the number of molecules of CO2, which is the moles here, is 4 molecules. Then the number of molecules of H2O is 5 molecules. Number 5. The unbalanced reaction of the combustion of propane is given below. First of all, we're gonna have to balance out the equation. So here we have, let me just, C is 3, H is 8, O is 2. Here, C is 1, O is O is 2 plus 1 and A. Wait, actually, just let me rearrange it. H is 2 and O is 2 plus 1. First of all, we're gonna have to balance carbon by making this 3. And then that will make this 6. Right? Okay. So after making this, after balancing out the carbon, we need to balance out the hydrogen here. So we need to make this 4, right? Which will make this 4. So this is balanced, this is balanced, the oxygen isn't. So how do we go from oxygen being 10 in the reactants to oxygen being 10, oxygen being 2 in the reactants to oxygen being 10 in the products? We just like put the coefficient of O to be 5. So let me remove everything. Oh, wait. So we have, okay, 5, 3, 4. Just let me put that back in. 5, 3, 4. Calculate the mass of water if 110 grams of propane is burned. Okay, so the mass of propane. First of all, we need to find the moles of propane, right? Here we have 110. They gave us the molar mass of propane to be 44. That will give us 2.5, right? Okay, so we have 2.5 moles of propane. They want the mass of water produced. Okay, so since the ratio of propane to water is 1 to 4, so we go 2.5 to x is equal to 1 to 4. So 10 is equal to x. So we have 10 moles of water, right? 10 moles of H2O. Now to get the mass, all we have to do is the moles times the molar mass. Here they gave us the molar mass to be 18, so we do 10 times 18, which will give us 180. Calculate the mass of propane required to produce 252 grams of carbon dioxide. Now we're gonna have to find the mass, first of all we're gonna have to find the moles of carbon dioxide, right? So we do 252 divided by 44 because they gave it here. 252 divided by 44, which will give us 5.72 or 5.7. Okay, so how do we go from, no, since here they said, here after balancing, the coefficient of carbon dioxide is 3, and the moles of, what's it called, propane is equal to x to 5.72 is equal to 1 to 3, and then we cross multiply. So we do 5.72 divided by 3, and we get that the moles of propane is 1.91. 1.91 mole C3H8. Okay, from that all we have to do is moles times molar mass. Here we have the moles, which is 1.91 times the molar mass 44, which will give us 83.89 or 84. Next question. 1 mole of gas under STP has a temperature of 0 degrees Celsius, pressure of 1 atmosphere, and occupies a volume of 22.4. Calculate the volume of O2 required to produce 180 grams of water at STP. Okay, so first of all, we need to find the mole of water. We have mass, which is 180, over the mole. So to find the moles, we do the mass divided by the molar mass. We have 180 divided by the molar mass 18. We have 10 moles of water, right? Moles H2O. Okay, so now we know that this is 10 moles. By most convenient ratios, we can find out that x to 10 is equal to 1 to 2. We cross multiply and we get that the moles of oxygen is equal to 5. So now to find the volume, all we need to do is 5 times 22.4 since they're asking here at STP. So which will give us 5 times 22.4 will give us 112. Number 8. Consider the following reaction. Calculate the number of moles of C2H4 required to react with 67.2 decimeter cube of oxygen at STP. Okay, so now we know the volume of O2 at STP. To find the moles, all we have to do is 67.2 over 22.4 divided by 22.4, which is 3. Okay, so now we know that oxygen has 3 moles. Now from here we can see that the moles is equal to the coefficient, which means that it implies for every other compound. So that means the moles of C2H4 is also gonna be 1. Number 9. Calculate the amount of heat produced during the formation of 512 grams of SO2. Okay, so first of all we're gonna have to find the moles of SO2 before everything else. So we're gonna have to do 512 over 64. 512 divided by 64, which is equal to 8. So we know that, so that's all we're gonna have to do now is multiply the heat by 8, because here it's 8. So how do we go from 1, which is the coefficient originally, to 8? We multiply the whole equation by 8. So times 8 here, 8 here, 8 here. Okay, so from now we're gonna have to do 296.8 times 8, which will give us 2374. Number 10. What is the mass of each of CaO and CO2 produced when 2 moles of CaCO3 decompose? So, okay. First of all, we're gonna have to. Okay, it's not that hard. So now we know that this is 2 moles, right? And since the ratio of all of the coefficients is 1 to 1, meaning that the ratio of all of the moles is 1 to 1. So this is 2 and this is 2. All we have to do from here is do the mole, which is 2, times the molar mass. CaO, they gave it here 56, which will give us 112. And then of CO2, 2 times 44, which will give us 88. 11. Iron oxide Fe2O3 reacts with carbon monoxide CO to produce iron Fe and carbon dioxide. 960 grams of Fe2O3 is mixed with 420 grams. Okay, so here we're gonna do this. Fe. So first of all, we're gonna have to find the moles, right? The moles of Fe2O3 by doing 960 over the molar mass, which is 160, right? What? So first of all, we're gonna have to find which is limiting and which is excess. So to find which is limiting, which is excess, first we need to find the moles of both. So we do 96. So this is for Fe2O3, and this side will be for CO. 960 over 160. 960 divided by 160, which will give us 6. Okay, so we have 6 moles here. Then here we have for 20 over 28, which is 15. But we're not done. So we have 15 moles, but we need to first of all divide by the coefficient, which will give us 5. And here we don't divide by the coefficient because it's already equal to 1. Okay. So now we know that that in the answer CO is 0 because they said here write 0 for the limiting reagent. So from here we use 5 moles like for each coefficient, right? So we do 5 times what? No, 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 no. As we said, the limiting reagent was 5 moles, okay? But part A or Fe2O3 is wrong here, so let me just remove it. Okay, and CO is 0, we already figured it out before that it's the limiting reagent. Fe, okay, so now we have, so remember we had 15 moles for 3, right? So 3 to 15 is equal to 2x. We get that x is equal to 10. Fe moles is equal to 10. So now we have the molar mass, which is 56, times the moles, which will give us 560. Then again we do the same thing for CO2. Since we know that CO, like the ratio between the moles of CO and 3CO and CO2 is equal because of the coefficients being equal, we know that the moles of CO2 is 15. So we do 15 times the molar mass of carbon dioxide, which is 44. 15 times 44 equals to 60. 660. Oh, what's this? here. Okay. So after we find that out, we need to find the volume of CO2 at STP. Okay, so since the... Are we on the correct question? Uh, okay, so here we go again. So we have C2, okay, so we have C, let me split it into two. C is 2, H is 2, O is 2. You know, I mean, uh, C is 1, H is 2, O is 1 plus 2. Okay, now to, first of all, to balance, we make this, like the coefficient of CO2 2. So this will make it 2. Then it will be 1 plus 4. Then, now to balance the last part out, we're gonna have to, how can I say it? Okay, so, okay, so first of all, we're gonna have to balance, balance the equation. So we have C is, wait, let me, C is 2, C is 2, H is 2, O is 2. Okay, so on the other side, C is 1, H is 2, O is 2 plus 1. Okay, so first we're gonna have to balance the C here. So this is gonna be 2, and this is gonna be 4. And now we're gonna have to balance the, what's it called? The oxygen. So why don't we make it 3 here and 2 here? Okay, so this will make it 6, but this will make this 4, and this will become 2. Then we're gonna have to do the same for C2. And then next we can balance the hydrogen. So we're gonna do this, and then these will be 4. But then we're gonna have to balance the carbon on the other side. So that will make it 4, and this is 4, but this will be 8. Now to fix this all, we can just make the oxygen with the coefficient of 5. That's it. Then this will become 10. Okay, let me erase this all. Okay, so let me save this. Okay, and then from here, all we're gonna do is put the what's it coefficients in the denominator, and then now this is the toughest part of the question. We're gonna have to calculate the mass at the end of the equation by using limiting and excess. So let me screenshot this. Can go here. Then they said, where is the molar mass? Okay, anyway. First of all, we're gonna have to find the moles of ethene. And then the molar mass will be 26. So the moles of ethene is 2. But we need to find the limiting and excess. So we're gonna have to divide by the coefficient. So this will be 1 and O2 to find the limiting or excess for oxygen. We're gonna have to do 320 divided by 32, which is 10, over 5, which will be equal to 2. So the limiting is C2H2, which is why we put 0 here. Okay, so from here, for C2H2, I mean for oxygen, we know that the mole, like how can I say it in a simple way? As we said, the moles of oxygen is 10. Wait, let me check some. Oh wait, my bad. Since here we're using the limiting reagent, which is 1, what we're gonna do is 32 times 5. So, like, what I'm trying to do is using 1 as the coefficient, as the mole per coefficient. So here, since the coefficient is 5, that means the moles of oxygen is 5. So we're gonna do 5 times 32, which is 160. And then for H2O, the moles is 2 times 18, which is the molar mass, which will give us 36. And then for CO2, we have 4 times the molar mass is 44. So 4 times 44 is equal to 176. Calculate the volume of CO2 produced at STP. Oh my. Okay. So we have the we have the where is it? We have the mass of CO2, right? So to find the moles, we do mass over molar mass, which is 176 over 44. We have 4 moles. So to go from moles to volume in decimeter, I mean in STP, we do times 22.4, which will give us 89.6. The decomposition of C2H2 releases 2602 moles of C2H2. Okay, so here there's a simple way. Since here we know that the moles of C2H2 is originally 2, and we can notice that the mass of CO2 here, 352, doubled from 176, right? Okay, so that means the moles of C2H2 doubled. So we have 4 moles of C2H2. So we're gonna do 4 times 2602, 4 times 2602, which will give us 10,400 and 10,410. For this question, we're gonna have to find out the mass by doing moles times molar mass. Here we have the moles of Fe2O3 as 1, and then we do 1 times 160, which is the molar mass, is equal to 160, obviously. And then for CO we do 3 times 28, which will give us 84. And then we do 2 times 56 to get 112. And then we do 3 times 44 to get 132. Number 14. What is the amount of heat released when 2 moles of H2 reacts? So here we can deduce the ratio 3 to 242 is equal to 2 to x, right? So we're gonna cross multiply. First of all, we're gonna do 242 times 2, which is 484, divided by 3, which is equal to 161. Number 15. What volume of O2 will produce 12 moles of CO2? First, we're gonna have to find like the moles of O2. So, how do we go from 3 moles to 12 moles? We do times 4, right? So we do times 4 to the entire equation, so instead of 5 here, it will be 20 moles. So, as I said in the last, like 2 questions ago, we go from moles to volume in STP, we do times 22.4, which will give us 448. Number 16. 6 moles of NO2 react with 3 moles of H2O. Okay, so this question is a simpler version of. Okay, sorry guys, I skipped like 4 or 5 questions because they're not included. Most of them aren't included. The rest are easy, which is why I didn't solve them. Okay. 352 grams of potassium iodide is mixed with 575 grams of lead nitrate. Okay, so first of all, we're gonna have to find the limiting reagent, Ki, then PbNO3, 2. Okay, so 352 divided by 352 divided by 127 plus 39, which will give us, okay, 2.12 over 2, 1.06. Okay, and then PbNO3 2, so 575 divided by 207 plus, okay, so NO3 alone is 14 plus 48, 58 times 206. And then this is 1.83, so we can tell that this is more. Okay, wait, what? How is it? Oh, they want the in excess, yeah, so it's gonna be this. And then since PBI2 has the same coefficient, like, oh my, since the coefficient per mole is gonna be 1.06, since we use the limiting, not the excess, so it's gonna be 1.06. Number 19. Okay. 6 grams of N2 reacts with 32 grams of O2. So for this question, we're gonna first of all find out the moles of oxygen because it's faster. Wait, what? We're gonna have to find the limiting reagent first, so we're gonna do N2 and then O2. Here we know it's gonna be 0.5, it's gonna be 1 mole, but then since here the coefficient is 2, so we divide by 2, which will give us 0.5 here, and then for N2 we do 6 divided by 14, which will give us 0.42. I mean 0.43, my bad. And since, okay, and for that, so then we know that we use the limiting for the moles per coefficient. So we do 0.43 times 2, which will give us 0.86. We do that times the molar mass, which is 14 plus 32, which is times 46, which will give us, what? Oh, wait, my bad. I did something wrong here. So, N2O2. This was 0.5, I got that right. But I forgot to say that it's N2. So it's 6 divided by 28. 0.214. And then do that times 2, then times 46, which will give us 19.7. The volume of the reagent in excess. We said that the reagent in excess was oxygen with 0.5 moles, right? And then at STP times 22.4, what? Mm, we're gonna have to find the moles first, which is 1. How is it wrong? Oh yeah, right, this question, like number 2 isn't coming in the exam, yeah, anyways. So for this question, we're gonna have to, okay, this is also by doing limiting and excess, but wait, the questions like these won't come. Okay, so here it's quite simple. How do we go from 4 moles of NO2 to 20 moles? We just multiply the whole thing by 5, and which means we do 3 times 5, which will give us 15. Oh my goodness. So for this question, we're gonna first of all balance everything out. So, okay, C is 2, H is 6, O is 3, or 2 plus 1. I'm gonna have to do this all over again.
So C is 2, O is 1 plus 2, H is 6. Then here we have C is 1, O is 1 plus 2, then H is 2. Okay, first we're gonna have to balance out the C, so we put 2 here, okay, so this is 2, then this means that, wait, no, I just erased everything, so this is 2, this was 1 plus 4 now, and then this is 2. Okay, so now we're gonna have to balance this 2 out, so we're gonna do this, then this will be 1 plus 4 as well. Okay, so this is balanced, this is balanced, this is okay. So it's just the hydrogen. So we're gonna have to do times 3, which means this will be 3, and then this will be 6. So, just wait. Okay, so that means we are going to put uh, a 3 here, which makes this 6, this 18, then this 3, then this 4. Okay, so now we balance this out. So now we're gonna have to balance the hydrogen out. This will take ages. So we're just gonna have to make this 9, then it will be 9 plus 4. At this point, guys, just balance it out and put the coefficient there. That's it. And then same thing for number 2. And then, okay, so 15, so H2O will have a coefficient of 3, right? So we're gonna have to multiply C2 5OH by 5 also. So to find the grams also, all we're gonna do is to find the molar mass, which is 24 plus 6 plus 16, which is 46, okay. Then 3 moles of H2O. Okay, so we're just gonna do 18 times 3, like molar mass times the moles. For this one, you're gonna have to balance it and then just put it in there, and then for number 2, just find the mass by doing the moles or the coefficient times the molar mass. And then, like for part 3, the total mass of the reactants will always be equal to the total mass of the product. So do 64 plus 96, then you'll just put it for both. In the above reaction, the total mass of the reactants is equal to the mass of products, so mass is conserved. For this one, you're gonna have to. So for the next few questions, is it only this question? Yeah, okay. So for 24, do like what we did before, balance. And then the ratio by mole is by using the coefficient. By mass, we do the moles times the molar mass. And then the ratio by volume, we do the moles times 22.4 since they want it in STP, but only for the H2O liquid. Since it's liquid, we just put the dash because it's negligible. At 2 mole CH4, okay, so what they mean here at 2 moles of CH4, just multiply the whole equation by 4 and you'll get that the moles of oxygen will be 4, so you do 4 times 22.4, which will give you 89.6, and then do 89.6 times 5 to get 448. So for this question, we're gonna have to find the moles by doing the moles divided by the molar mass, 14.2 divided by 71, which will give us 0.2. Then, since the ratio between Cl2 and NaCl is 1 to 2, so we just multiply the moles of Cl2 by 2, and then to find the mass, we just do mass times molar mass, which is 0.4 times 58.5. Right, okay. 26. For this question, we're just gonna have to balance the equation, and then since they want 6 moles of iron chloride, we multiply the whole equation by 3, and we find out that we need 9 moles of Cl2. A sample of 0.5 moles, okay. So for this question, we're gonna have to do 0.52x is equal to 2 to 13. So we're gonna do 13 times 0.5, which is 6.5, divided by 2, which is 3.25. And then to find the volume, all we're gonna do is 3.25 times 24, and then do that times 5 to find the volume of air. Number 28. Let me see how many questions there are left. Okay, so we have question number 28. To find the moles, we're gonna do 0.109 divided by 65.4, which will give us 1.67 times 10 to the power negative 3. Since in the equation, the moles of hydrogen, I mean the coefficient of hydrogen is equal to the coefficient of zinc, that means the moles are the same. Look, okay, so now to find the volume, which is what they're asking for here, we do the moles times 24, which is 0.04, but here they're asking it to be in centimeter cube, so we do 0.04 times 1000, which will give us 40. For this one, we're just gonna have to balance it and then put the energy like at the end because they said here releasing. Number 30. Uh, the maximum number of moles. Okay, yeah. So we're gonna find out the moles of carbon for 16.8 divided by 12. Okay, since carbon has like double the moles of C2H6, all we're gonna do is divide the moles of carbon by 2, which will give us 0.7. Last question. According to the balanced equation, 89.6 decimeter cube of pH3. So just divide by 4. 89.6 divided by 22.4. Just let me this here. That will give us 4. Okay. will, will decompose to form a negligible volume of P4 because it's a solid, and then to find the volume we just do 22.4 times 6. That's it. 134.4. Thank you guys so much for watching this video. Hope this video was helpful, and I'm sorry for skipping like 5 6 questions because my audio was off. Good luck in your exam and goodbye.